Hello again. We are finishing up the sections that we cover in Chapter 10 with 10.4, Calculus in Polar Coordinates. And just a quick refresher, 10.1 was parametric equations, and then, of course, calculus in that setting. Section 10.3, polar coordinates, and, of course, now calculus in that setting. We're going to look at areas, arc length, and tangents. So let's start with areas. So if you remember the area of a circular sector, area of a circular sector is A equals 1/2 r squared theta, mandatory theta in radians. So what does this mean? Well, if we have a central angle theta, and if we want to determine this area in a circle with a radius r and central c, the area of this circular sector has this formula: 1/2 the radius squared times theta, but theta in radians. Careful, not degrees. So similarly, when we want to determine in the area of a curve, let's say in polar coordinates, that's what we are going to determine. We're going to determine this area, and we're going to integrate from theta equals A, whatever angle, till theta equals B. So therefore, this area will have the formula A equals the integral from A to B, of course from 1/2 r squared, and of course d theta. Okay, so let's see how we apply this. Oh, and of course that's clear, right? That theta is between A and B. Let's write it again, between A and B. Okay, so let's look at a few examples and see how we calculate the area. Let's start with problem 1 on page 699. And we are given that r equals the square root of 2 theta, and the angle is between 0 and pi over 2. And we're asked to find the area of the region that is bounded by the given curve and lies in the specified sector. Okay, we're following the formula. So the area equals the integral. We can put 1/2 outside, of course. The integral from 0 to pi over 2 from r squared, which is 2 theta, d theta. Well, obviously it couldn't be easier than this. Let me move this a little bit. Okay. So 1/2 with 2 will go away. So this is theta squared over 2 from 0 to pi over 2. There is no point in plugging in 0. Of course, we have to start with pi over 2, but I was just pointing out that there is no need because it will be 0. So pi squared over 4 divided by 2 is pi squared over 8. And that is the area enclosed. Let's move on to another example. I am on page 2. Page 2. Okay. So let's also look at 4 on the same page, 699. And it has r equals 1 over theta. And theta is between pi over 2 and 2 pi. Okay, so that's all we need to determine, the area. So 1/2 outside, the integral from pi over 2 to 2 pi from this squared, which is 1 over theta squared d theta. Remember what this is? We talked about it a long time ago in chapter 6 and 7 and Calc 1. So this is negative 1 over 2, 1 over theta. Because 1 over theta with minus in front, prime, is 1 over theta squared. And of course from pi over 2 to 2 pi. Leave the constant outside, plug into pi, 1 over 2 pi minus, when we plug in pi over 2, we have to flip, so minus 2 over pi. The least common denominator is 2 pi. 1 minus, and this one needs a 2. So 1 minus 4 is negative 3. So this will be 3 over 4 pi. And that is the area enclosed between pi over 2 and 2 pi of this loop, or whatever. We didn't graph it, so whatever this represents. Okay, Let's see what else we should look at. What they recommended. Oh, yes. They recommended problem 7. So let's take a look. Here's problem 7 on page 700. And this time it's the function is the polar equation is given to us, of course. 4 plus 3 sine theta. And they're giving us the following graph of this curve. So it looks something like this. And the shaded area is right here. So first of all, let's look at the angle, because the area will be 1/2 the integral from low high for the theta, 4 plus 3 sine theta, everything squared d theta. So obviously you see this is the direction of negative pi over 2, and this is the direction of pi over 2. So it's between negative pi over 2 and pi over 2. That's simple. Okay, so let's find this area. So I'll continue here. 1/2 the integral from negative pi over 2 to pi over 2. And now I have to square. I squared a binomial, so I have to get a trinomial. First term squared, 16, plus 2 times the first times the second, 6 times 4, 24, sine theta, plus 9 sine squared, d theta. I think I should move on to the next page. Let me see if I can squeeze anything in here. I can a little bit. So 16, the integral of 16 d theta will be theta. 16 theta from negative pi over 2 to pi over 2. The integral from 24 sine theta, because this is an odd function, and because the interval is symmetric, the integral from an odd function with a symmetric interval will be 0. So you can also already disregard this. Plus 9, the integral from negative pi over 2 to pi over 2. At this point, I have to change this into, if you remember, 1 minus cosine twice theta over 2 d theta. Okay? Remember the formula? We discussed those in chapter 7. Okay, moving on. I'm on page 3. I managed to squeeze a little bit in there. Okay, so equals here and page 3. Okay, so 1/2 16 pi over 2 plus pi over 2 will be pi. 16 pi. This is done. Then I have 9/2. Why can't you stay? Okay, so 9/2 going outside. The integral of 1 d theta will be theta from negative pi over 2 to pi over 2. And now minus 9 over 2. And cosine, so the integral from cosine 2 theta will be sine 2 theta over 2 from negative pi over 2 to pi over 2. I use the bracket so I don't forget about 1/2. Okay, continuing. So leave the 1/2 still out there. So this is 16 pi plus, again, pi minus pi over 2 is pi. So I have plus 9 pi over 2. And here I have negative 9 over 4. But let's see what happens when I plug in pi over 2. When I plug in pi over 2, 2 times pi over 2 is pi, so this is 0. When I plug in negative pi over 2, will be sine of negative pi, so this whole thing is 0. So 2 times 16, 32. 32 plus 9, 41 pi divided by 4. And that is the final area. Okay, so let's see, how are we with time? Good. Let's move on. Let's take a look at what is it next. Let's say 15. On the same page, 700. And we have r equals the square root of 1 plus cosine squared 5 theta. It says graph the curve and find the area that it encloses. Okay, so we're going to grab the calculator. Make sure that, go back to mode. Let me see, can you see? I hope you can see this. Okay, so my calculator is already set in polar coordinates. So go back to y equals. Clear whatever you have and just punch in the square root of 1 plus. Please, I don't know, maybe there is another way, but I prefer putting parentheses and the square outside. Not outside of the square root, of course. But I enter it like this. Cosine 5 theta, everything squared. With plus 1 in front and, of course, the square root on top of everything. So, parentheses, cosine 5 theta, close, close, square. I normally like to put parentheses also here. These are not really necessary depending on your calculator. But these are not really necessary, but I always like to put parentheses for the quantity that is under the square root. Okay, so let's hit on graph and see what happens. Oh, quite nice. Let me see if I need to zoom in to see it better. Okay, no, that was the best. To zoom out. Perfect. So here's the graph of the square root of 1 plus cosine squared of 5 theta in polar coordinates. Okay, so they're asking us to find the area enclosed. All we need to determine is the area. So as you see, this is a symmetric curve, so all I have to do is multiply by 4, and obviously this angle here is 0, and this angle here is pi over 2. So I will conclude that the area equals 1/2 times 4 of those because theta goes from 0 to pi over 2. 0 to pi over 2. Of this expression squared, which is 1 plus cosine squared of 5 theta, d theta. So let's calculate this integral and see what we get. Okay, so I have in front actually a 2. Then I have the integral of 1, which is theta, from 0 to pi over 2, plus the integral from 0 to pi over 2, if you remember, I have to change this into 1 plus cosine 10 theta divided by 2 d theta. And let's see what we get. So pi over 2, there is no point in plugging in 0, so pi over 2, so 2 outside, and pi over 2, and then plus 1/2 the integral of 1, which will be theta, from 0 to pi over 2, and plus 1/2 the integral from cosine 10 theta is sine 10 theta over 10, from 0 to pi over 2. Okay. So we have here, again, let's plug this in just for a moment. So pi over 2 times 10 is 5 pi, but sine of 5 pi will be 0, and this will also be 0. So this whole thing is 0 again. So all we have is 2 pi over 2 plus pi over 2 with 2 in front, 1/2 in front, right? So this is pi over 2 plus pi over 4. So this needs a 2. 2 plus 1 is 3. So I have 2 times 3 pi over 4. After simplification, this is 3 pi over 2. And we determined the area enclosed. Okay. Let's see if anything else we should do about area. What else is here? Let's look at 17 maybe. Let's see how we are with time. Yes, still good. Okay. 4. Well, let's look at 17. And that is on page still 700. And they're saying, find the area of the region enclosed by one loop of the curve. So r equals 4 cosine 4 theta. Okay. So let's grab our calculators. Okay, go to y equals, clear, and let's put in 4 cosine 4 theta. Okay, and let's graph. Let's zoom out and see what happens here. Okay, so 4 cosine 4 theta. Good. So what I would like to determine, and I have to determine, it just says one loop. Obviously, it's all symmetric. It doesn't matter which one I determine. However, we have to determine the angle theta. So let's say I'm going to graph here just one piece, one of these loops. So I need to determine, in order to find this area, I need to determine angles. So this is theta equals whatever. I'm going to call it A for now, and theta equals B. So we can start the area. So the area will be 1/2 the integral from, I have to determine A, I have to determine B, from this squared, which will be 16 cosine squared 4 theta d theta. I can continue before we determine, of course, the angle. So let's see how we do this. So notice that for this theta, as well as for this theta, r is 0. Because the curve is right here. This is where the curve is. So when r is 0, we have these two thetas. So let's set r equal to 0 then. So then 4 cosine 4 theta equals 0. I think I copied the problem incorrectly. It was at 3 theta. So sorry. So please correct that. So it's 3 theta. Okay. And of course, I have to make the correction here. Let's take a look. Let's see what happens. Okay. So then for exactly the same I copied, but that is the correct graph for 3 theta, 4 cosine 3 theta. Sorry, I entered 4 by mistake. Okay, very good. So in order to solve this equation, we know from here that cosine 3 theta must be 0. So remember from trig, this is the unit circle. Cosine is 0 at this point and this point, right? So at this point, we have pi over 2, and at this point, we have 3 pi over 2. So then 3 theta equals pi over 2, and 3 theta equals 3 pi over 2. Okay. Since we see the symmetry here, we really don't need to, furthermore, theta equals pi over 6. And because of the symmetry and because we have a negative angle and a positive angle, so obviously we can simply conclude that the area will be between negative pi over 6 and pi over 6. We don't have to continue and determine all other possible values of theta. So that would be good enough. So this is negative pi over 6, and this is pi over 6. Okay, so then I'm going to jump over all this with a square. And I have 16 divided by 2, which is 8 in front. Also remember the symmetric interval, and this is an even function. Symmetric interval and even function reduces to twice the integral from 0 to pi over 6, which is easier to calculate, from cosine squared, which we know is 1 plus cosine 6 theta divided by 2 d theta. Okay, so we continue. Yes, this goes away again. So we have an 8 in front. And we have the integral from 1, which will be theta from 0 to pi over 6, and plus the integral from cosine 6 theta, which is sine 6 theta over 6 from 0 to pi over 6. So this is 8 times pi over 6. Pi over 6 will give us sine pi, which is 0, and 0. So this is again equals 0. And I will simplify, and I get 4 pi divided by 3. And that is the area. We'll continue in the next video. I got 20 minutes. Thank you.